Okay, so in this video, we're going to kind of go through the study guide and explain a few things to you, just to make sure that it's clear. So, first thing we'll start off with is evaluating. When you evaluate a log, you're thinking of what's the exponent? What's the exponent I need to raise my base to get my answer? So you can kind of rewrite this in exponential form as 2 to the y equals 8. What does y need to be? Well, y needs to be 3. 2 to the third is 8. If I'm looking at this, it's 6 to the y equals 1 over 36. Well, that immediately tells me that's a negative number, right? So I could think of it as 6 to the y equals 6 to the negative second. So y has to be negative 2, right? I raised 6 to the second power to get 36. Since it's the reciprocal, it has to be a negative 2, right? So let's look at little things like this. ln of e to the fifth. Well, that 5 kind of comes to the front, and then I have ln of e. ln of e, that's what I raised e to get e. So this is 5 times e to the y equals e, right? Well, that's 1. 5 times 1 equals 5. All right? Same thing here. This becomes 3 times 4 times ln of e. ln of e is 1, so this ends up being 12. All right, a couple other ones. 8 to the first. Anytime you take the log of 1, your answer will always be 0. But if you take the log of a negative number, it doesn't exist. You cannot take logs of negative numbers. Okay, you can't take the log of 0. Okay, so most of you were doing all right with evaluating, so try those on your. Let's look at I real quick. There were some issues with this, right? This is 0.01. That 1 is in the hundredths place, so this is the same thing as log of 1 over 100. What do you raise 10 to get 100? The second power. So since this is reciprocal, it has to be negative 2. Make sure you're paying attention to your place value. All right? So, expanding expressions. Multiplication becomes addition. So this rewrites to log base 2 of 32 plus log base 2 of 8. Now in this case, I know that 2 to the fifth power is 32, so I can rewrite that log as 5. And I know 2 to the third power is 8, so I can evaluate that log and say it's 3. So whenever you can evaluate, you should evaluate. All right, but that's multiplication. Division becomes subtraction. Log base 5 of 25 minus log base 5 of 125. Well, that gives me 2 minus 3, which is negative 1. Now what's really interesting, we can check this 25 over 125. That's the same thing as log base 5 of 1/5. What do I raise 5 to get 1 over 5? Negative 1. So a lot of these times, this is an alternate way of evaluating. You don't have to do it this way unless the directions tell you to. So again, multiplication. This is 3 times x, so this becomes log base 6 plus log base 6 of 3 plus log base 6 of x. All right? And there's nothing to evaluate there, so we'll just leave that alone. Here we have a exponent. Exponents, again, as I discussed earlier, want to go to the front. So 5 times log base 3 of x. And that's all you can do with that. So let's talk a little bit about radicals. Log base 4 of 4 plus log base 4 of the square root of x. Alright, because this is multiplication, you have to expand that. And what I can do now is log base 4 of 4, anytime you take the log of a number that has the same base, it's always going to be 1. And a radical is really just a rational exponent. So log base 4 of x to the 1/2, and then exponents want to come to the front. So you end up with 1 plus 1/2 of the log base 4 of x. And that's your final answer. Okay. But again, I think expanding and evaluating, most people were doing well with. Condensing, right, is to pull it all back in. I see subtraction, so there's a single log, log base 3 of 7 over x. I see addition, so I'm going to be multiplying, but let's first take care of this multiplier in the front. Bring it back as an exponent. So log base 5 of x squared plus log base 5 of 3. Now I'll condense it into multiplication as a single log, log base 5 of 3x squared. Right? So take care of those multipliers first. So here, right, I got a 1/2 multiplier, which turns into a radical. So I can rewrite this as log base 10 of the square root of x minus log base 10 of 4. And I don't really need that base 10. It's subtraction. So my answer ends up being log of the square root of 10, square root of x, sorry. Log of the square root of x over 4. Okay? Order of operations, you should always be working from left to right. So log base 3 of 4 plus log base 3 of x squared minus log base 3 of 5. So I'm multiplying 4 and x squared. So that gives me log base 3 of 4x squared, and then I'm subtracting, so I'm dividing. And that is condensing. Alright, these evaluations need to be done in the calculator. Again, if your calculator does not have the ability to change the base, then you will have to use your change of base formula. So I would rewrite this as log of 7 over log of 4, and I would put that in the calculator. Log of 7 divided by log of 4. Make sure you are closing your parenthesis before you're hitting divided by, otherwise your answer will not be correct. Alright? So again, that's the change of base formula, which is different than the division, right? You change subtraction into division as a single log. The change of base is when you separate into two separate logs. Okay? And then another issue that people had was finding the inverse. If I give you an exponential function and I want you to find the inverse of that exponential function, then I need you to write it as a logarithmic function. So the first thing you need to do is change the x and the y. So this becomes, we'll write it out first, 2 to the x minus 3 changes to x equals 2 to the y minus 3. But that's not the end. That's changing x and y is just the first step. Now I need to put it in logarithmic form. So I'll say log base 2 of x equals y minus 3. And now I need to solve for y. So I'll get y equals log base 2 of x plus 3. And that is the final answer. That is the log, or that is the inverse, is when it's in logarithmic form. The same thing if I give you an exponential as if I give you a logarithmic. I need it to be rewritten into an exponential equation solved for y. So the first step is to change x and y. So we'll say x equals log base 2 of y plus 4. And then I will rewrite that in exponential form. Exponential form has 2 to the x equals y plus 4. And then I'll solve for y. So y equals 2 to the x minus 4. Notice I'm not subtracting the 4 from the x. I'm subtracting it from 2 of x. Right? Just like over here, I'm not adding 3 to x. I'm adding 3 to the log of x. Right? So you want to be careful about that. But generally speaking, that is how you rewrite and find the inverse. Okay? You have to switch x and y, and you have to rewrite it. Alright? Some of you were only doing switching x and y, some of you were only rewriting, but you both need to do both things. Switch x and y, and then rewrite. Alright? In terms of solving, this is the last thing we'll talk about. This is the last thing that'll be on the quiz, or on the test rather, sorry, is if I have two functions that have different bases, you could take the log on both sides, but in this case, I know that an 8 can become a base 2, so it's much easier to get it to a base 2. So this is 2 to the third, and then I'll multiply my exponents, so 2 to the 3x equals 2 to the x plus 1. Now it's much easier because now all I have to do is set the exponents equal to each other. Because if it's the same base, then the exponent, if they're equal, then the exponents have to be equal also. So 2x equals 1, and x equals 1/2. Okay, so let's take a look over here. In this case, you need to isolate your exponential term. So I'll subtract 6 on both sides. So now I have 1/2 of e to the negative 2x equals 1. Then I'll multiply both sides by 2 to get rid of that. E to the negative 2x equals 2. So in this case, what I'm going to look at doing now, since I can't get a 2 into a base e, I will take the ln of both sides. So ln of e to the negative 2x equals the ln of 2. Well, that negative 2x comes to the front, so negative 2x times ln of e equals the ln of 2. Well, that's 1, so I get negative 2x equals the ln of 2, divided by negative 2, and x equals the ln of 2 divided by negative 2. And this is the exact answer, but in most cases we're going to ask you to type that into the calculator and get a decimal answer. Alright, and that's solving. Let's take a look at a few more. We could take a look at number D. So here the log has been already isolated. There's nothing else to do to either one of these. So to solve this logarithm, I'm going to rewrite it into exponential form. So I have a base 2. This becomes my exponent. The 3 becomes my exponent. So 2 to the third equals 25 minus x. Well, 2 to the third is 8. 25 minus x. So x equals 17. Okay? When you're solving, the only way to get the variable that you want to solve out of the logarithm is to rewrite it in exponential form. And that way you can work with it. Same way as that if it's in, here we have log, we'll say 10 to the x equals 31. My exponent is the variable. How do I get that out? Well, I rewrite it in log form. Log of 31 equals x. Now my variable is free, right? So whenever your variable that you need is in an exponent, you rewrite it in logarithmic form. When the variable that you want is in a logarithm, then you rewrite it into exponential form. And by doing those two inverse operations, you're able to evaluate and isolate, right? Let's look at f. Minus 4 minus 4. So 3 times the log of 2x equals 12 divided by 3. So log of 2x equals 4. Again, now I see that my variable is in the log. So exponential form. That has a base 10. So 10 to the 4th equals 2x. Divide by 2. Divide by 2. 10 to the 4th, well, that's 4 zeros. Divided by 2 equals x. So that is 5,000 equals x. Okay. And kind of the most complicated ones we'll have here are things like h. Alright? So it's addition. I have to have those logs together. So what I'll do is multiply them. Log of x plus 2 times log of x minus 1 equals 1. So now I can multiply those together, FOIL it. So log of x squared plus x minus 2 equals 1. Now that I have it as a single entity, I can rewrite it as 10 to the first equals x squared plus x minus 2. And that means I'll have to bring that 10 to the other side, and I end up with, change color here, x squared plus x minus 12 equals 0. Because I'll subtract 10 on both sides. And then I have to factor that to x squared plus 4, x minus 3x minus 12 equals 0. So x plus 4 equals 0, x minus 3, if I factor it. So x equals negative 4, or x equals negative 3. Now, you have to plug those back in and make sure you're not going to get something that doesn't work. So if I put a 4 in here, I get log of 6 and log of 3. If I plug in the negative 3, I get log of negative 1 and a log of negative 4. Well, you can't take the logs of negative numbers, so my answer ends up only being x equals 4. Okay? So that's solving. Hope this video was helpful for you. Again, if you have any questions, we'll be here Monday morning, and we have returns if you're in a later period. All right.